This is a real number line because all real numbers fit on it. There's 1, 2, 3. You can see all those, but then you might say, well, hold on. What about the square root of 4? What is the square root of 4? 2. Boom, there it is. What about 3 halves? Well, that's 1.5. We know we can plot that between 1 and 2. Now, what happens when we have a number like the square root of -4? I can't plot that anywhere because it doesn't exist. It's not real.
5, 6 is complex numbers. Any imaginary number I is any number whose square is -1. So I squared equals -1. And because of that fact, that means I has to equal the square root of -1. If you think about it, we've done the square root of 5. We square that. This is the square root of 25, but the square root of 25 is 5. So really, anytime you square a square root, it equals itself without the radical, without the square root. So I being squared would be the square root of -1 squared, which is -1. A complex number is any number in the form a plus bi, where a and b are real numbers, and b cannot equal 0. If you think about it, if b equals 0, then there's no more I, which means it can't be a complex number. All right, so let's simplify imaginary numbers, or simplify square roots. Okay, so like I already established, we can't necessarily take the square root of the negative, but we can remove the negative because of the fact that we know the square root of 8 can go to -9 times 8, -1 times 8, and this is all a square root. And the square root of -1 is I, so we remove the whole negative aspect and put the I out in front of the radical, and we have the square root of 8. But we also have to remember that this square root of 8 can be simplified, right? Because we can go to 4 times 2, which the square root of 4 is 2. So really we have 2I square root of 2 is the square root of -8 simplified. This actually pretty simple case. Square root of -36, but we can't do the negative, so we can take, actually I'm not even going to write that. We can take the I out, or take the negative out, so we would have I, and then the square root of 36, which we know is 6, so it would be I times 6, or 6I. I'm going to let you do the square root of -12, so why don't you go ahead, pause the video, and do that. And with that, you should get 2I square root of 3, because you take the negative out, take the I out, and you'll have I square root of 12. Square root of 12 can get broken down to 4 times 3. Square root of 4 is 2. So 2I square root of 3. And then we have this, which is really no different than all the others. We take out the I, or the negative, so then we have square root of 18. That can get broken down to 9 times 2. Square root of 9 is 3. So we have 3I square root of 2, and then we have this plus 7. The only thing is, because complex numbers should be written in a plus bi form, I would rewrite this as 7 plus 3I square root of 2, and there's your answer. You can't combine them because they're not like terms. It's just like if you had 7 plus 3x there, you can't combine them. So then we'll have where we have to add and subtract complex numbers. Okay, now these are actually kind of book problems we're going to be working with in class tomorrow. So with this, you have to add or subtract them. So we'll have to simplify the square root first, so then we can combine like terms. So the square root of -49, this will actually go to 5, 5 plus 7I, and then and then we have -2 plus 6i. How I got that, take the I out, and then the square root of 49 is 7. Take the I out, square root of 36 is 6. And then it's really just a simplifying expression problem. Combine your like terms. So 5 and -2 are like terms. So this is going to equal 3, and then 7i plus 6i is 13i. So there's your answer, 3 plus 13i. So here with subtraction, just like adding, you subtract like terms. We do have to simplify it first, and this will go to 8 plus 3i. Square root of -9 is 3i. Because take the I out, square root of 9 is 3. And then we have -2 plus 4i. And then again, subtract like terms. So we have 8 minus 2, which is 6. And then we have 3i minus 4i, which is -1i, or just -i. So 6 minus 1i, again, it's in a plus bi form. So we're good. This last one, simplify what's inside the grouping symbols first. So that goes to 3 plus 2i. And then just like before, it's just a matter of combining your like terms. So we have 7 minus 3, which is 4. And then we are not taking an I. So we have 0i minus 2i. So it's actually going to be -2i. Or if you want, you can look at it as distributing the negative and then adding your like terms. You can do that here too. Multiplying complex numbers. Again, same process as multiplying numbers with x. If this were x, we would do 5x times -4x, which would be -20x squared. But it's not an x, it's an I. So because it's an I, it makes it a little bit different, because you learned back from the first page here that I squared equals -1. So when we go to this, -20 times I squared is really positive 20, because you're doing -20 times I squared, which is -1. So -20 times -1, positive 20. This same scenario as if it were x's, you have to double distribute or FOIL, however you learned it. So you do 6 times 4, which is 24, and then 6 times -3i, -18i. And then we have -5i times 4, -20i. And we have -5i times -3i. So that is positive 15i squared. Okay, great. Now we have, just like if we did it with x's, we would have to combine our like terms. So it would go to 24 minus 38i, and then plus 15i squared. Again, because of that little fact that I squared is actually -1, this whole piece is actually -15. Because positive 15 times -1 is -15. Then we can combine our like terms. 24 minus 15 is 9.